beans. So, 4.1. Wow. Weren't we like an 8 or something before we took off to come back? But it's okay. So take a look at some of these. I think you have already seen a lot of these topics before, or these criteria for today. We're going to do angles and radian measures today. Radians are something that people struggle with, that idea. But angles, everyone's okay with what an angle is? Give me thumbs up if you're okay with, you're like, you know what you're talking about when we talk about angles. Thumbs up, thumbs down. Okay, so an angle is simply going to be if you have some ray or segment and then another that shares the, what's this called, the vertex? That shares a vertex, that distance between them creates an angle. Okay? Now, there's this other thing which is kind of weird, radians. Someone want to explain a radian? No? I'm not going to Dora this thing. What do you guys do? Go ahead, tell us, Jay.
You tell me. You tell me.
What's a radian?
I don't remember.
The way I think about radian is simply like this. All it really is something that helps me convert from angles, that's something that's not really measurable in distance, to something that's more usable. So if I wanted to find a distance, I'd have to go through this radian measure thing. It's not something that actually.
With like the pi over 3, pi over whatever.
Right. You know how you're doing that unit? What's it called? Hold on. I know this word. When we used to do dimensional analysis. It's fancy, huh? It's just some process that you had to go through. So we don't really go out there and measure, 55 radians or whatever. We're just gonna. It's just some unit of conversion. Okay. So we'll do that. We got radian measures. We'll convert between the two. We'll draw angles in standard position. Coterminal. Coterminal. Riley. Coterminal. What does that mean? What is coterminal? Guys, think back to, 6th grade when you had to look at words and look at those pieces and break them apart and try to figure out what it means? Coterminal. What's terminal mean? Oh, yeah, it is though. It's an airport, but that's where the flight ends. That's why you go to that terminal, or it starts. So, but it usually ends there, right? So if it ends, terminal ends, and what does co mean? Together. So it just ends at the same spot. So if I have this, I'm pointing at MJ, right? Right now, let's say MJ is 0 degrees, okay? And then I turn a certain number of degrees, and I stop, or I end at the same place. That would be considered coterminal. That's it, okay? So I end at the same spot. So I would have 0 degrees, and then of course you knows how much I rotated, right? How much did I rotate? 360. So 0 and 360 are both considered to be coterminal. Okay. If I was up at 90 degrees, what next degree value would be coterminal with it? Positive. Next positive. 260. Well, if it's would the negative one be coterminal? No, because this one's pointing up, the other one's pointing down. So I'd have to go all the way around how many degrees to get back to that spot? 360. So what's 360 plus 90? So that would be coterminal with that. Okay. Find the length using your angular speed. Okay, cool beans. So here we go. Here's an angle. Angles formed by two rays, bop, bop, have a common vertex. Here's our initial, then here's that degree measurement. Something to be aware of when we're doing like trig and geometry. For some reason they don't like the English alphabet and they want to bring in the Greek alphabet. I don't know if you've noticed that. We'll use some X's and Y's for lengths and stuff, but usually when we're talking about measures, in this case we're using theta. This 0 with the line through it is actually theta. It's the Greek letter T. Theta, theta. Any questions on this slide? I hope I'm not insulting anybody. Continue? No, I see right. chair's being dragged, huh? We're good? All right, cool. So, still talking about angles. Understand that an angle is in a standard position if the initial side starts on the x-axis. So kind of at 0 business. And then the terminal will just go around and rotate around, right? So initial, terminal, initial, terminal. If you're rotating your terminal side counterclockwise, which is the way we want to go, that is a positive degree measure. If you do it backwards, clockwise, then this is going to be a negative angle measure. Positive angle, negative angle. So let's say that alpha looks like this, guys. I don't know if you can see it. Alpha, let's say alpha was 100 degrees. Let's say theta was equivalent in the negative direction. That would be negative 100 degrees. Is 100 a good number for that as an estimate? Why? Who said
If it goes past 90.
Because it goes past 90 and doesn't go farther than 180. Cool. I'm just checking. Just checking. Just checking with y'all, man. What's up?
What does that say? Where it says 100?
This? This is the variable. It's called alpha. That's the Greek letter for A.
Why not just do an A though?
'Cause that's
Like I said, in trig they do that a lot.
That's just X.
So you're gonna be seeing that. Yeah, well, if you want to call it X in your mind, go for it, bro. It is
Call it
extra.
A.
It is extra. And over here we've got theta. I can't draw alpha very well. That's what my alpha looks like. Look like a little goldfish trying to swim away. But he can't because his fins are all broken. We're good? That sounds good. I had to borrow my wife.
So small.
But I can't chug. Okay, we're good? Yes? We already talked about positive and negative. If you move counterclockwise, your positive angle. If you move clockwise, then you're going to be considered a negative angle. Okay? Now, here's a word, I don't know if you guys have heard this. If an angle lands right on one of the axes, like 0, 90, 180, or 270, the angle is called
Quadrangle. Wait.
quadrantal.
Yeah, that was close.
Quadrantal. I believe that's how you say it. Any English peeps in here? Where are my grammar Nazis at?
That's just such a weird thing to say, Mr. Roadhouse. My
No.
grammar Nazis?
You never heard that before?
No.
I heard that last year when someone always corrected me with mine. And like, who made you the grammar Nazi? I was like, damn. I thought it was funny. What's up?
Could you go back a slide?
Could I go back a slide to the positives, negatives?
Yeah, I want to
No way.
We should have written that from the last one. But okay. Is it me or is it hot?
No, it's not hot. It's cold.
It's freezing.
Look, I'm sweating.
It's still cold.
Sweating. Woo.
Someone's nervous.
Not at all. This is my sweater vest.
Chuck. My second grade teacher told me Chuck wasn't a word.
But we all understand it, so yes, it is a word. I remember my English teacher used to say ain't a word, and now it's in the dictionary. How about that, Miss Sturgill? Yes, I remember her name.
You're mad. You're mad about 4411 though.
Man, dude, she would. Some of my English teachers, they just traumatized me. All right, cool. Let's move on. Some of the other rules that you learned from geometry: acute angles measure less than 90. Right angles measure 90. Obtuse angles measure 90, but less than 180. And what we call a straight angle measures a $1.80. Who that is? I know. Special. Mail delivered all the way to you. Do you guys remember what this is called? What type of angle is this? Yes, but if the vertex is right at the center of the circle, boom! Say it nice and loud so I can hear on the other side.
I was guessing a central angle.
It's called a central angle. A central angle.
Oh, it's central angle.
That doesn't make sense.
What happened?
What?
What doesn't make sense?
That.
What a radian is?
Yes.
Give me a radius. Hmm? 12? So if this is 12, and we've got a circle, right? Once I've traveled those 12 units, that would be considered a radian there.
Oh, so it's like a distance.
Mm-hmm. Now I think everybody knows how to do the conversion, right? How many radians? No? Okay. Let me see if it's going to be in one of my slides. I don't want to jump the gun. Has anybody ever heard the word radian before? Did you guys do radians in geometry? I feel like you should have seen this already. But nobody's asking either, so it's kind of... I'm going to just go into a lot of detail as much as I can then. All right. All right. I know what to be cautious for now. Thank you.
Evan just takes any chance he can get to bash on Mr. Raza. I just don't stand by that.
Yeah, please don't. Who is that? Is that you?
I love Mr. Raza.
Yes.
I'll leg drop you, bro.
Wait till Mr. Rosa next year.
Okay. Please write down this formula. Radian measure. Consider an arc of length S on a circle of radius R. The measure of the central angle theta that intercepts the arc is S divided by R.
So is that how you find the radians?
Yes, that's how you can find radians. Let me try this. Let me try this. Okay. How many degrees are here? 0. How many degrees are here? 90. How many degrees are here? 180? Do do you remember that this is also equal to pi?
Yes.
We're good with that? Pi radian. So pi is like a radian measure. Okay, so this is pi radians, correct? So let me ask you this. How many radians can I have from here to there? No, that's degrees. How many radians will I have from 0 to 180? How many? Give me a number, not pi, not a symbol. How many radians will I have? 3.14. So I know that from here to here, there will be exactly 3.14 radians, correct? Now, circles can get smaller or they can, I like this, they can get larger, they can get smaller, correct? But there will always be a relationship on that radius, okay? So for example, let's see if I can do this. 1, 2, 3. Nah, that's too much, huh? Maybe the last one could be bigger. That look decent? Does that look decent? So let's say that they were all equal except for that one, okay?
Is it 90 equal like 2 pi or like half pi or something?
Yeah, half pi. You're good? Okay, cool.
Equals 2 pi, right?
No, 0 is 0.
Down.
This is, oh no, yes. Once you full rotation? Once you full rotation, yes. But that would not be 0. That would be 360 degrees would be 2 pi. Okay? So let's make sure we got this down first. Everyone's okay with that? If I go to 180 degrees, that's pi radians, which is equal to 3.14 radians. Then yes, if I wanted to go full rotation, then I've got 2 pi, which is 260 degrees, which would be 6.28 radians. Okay? Now, please pretend that these are equal, right? Because how many radians would this be? How many radians would this be? How many radians would this be? 3. And how many radians would be here? 3.14, right? But that is assuming that the radius of this is 1. That's assuming that the radius there is 1. Okay, so what does that mean? That means that I have a circle, and the radius of it happens to be how much? 1. So I can go, oh, that's 1 radian, 2 radians, 3 radians, correct? But what if I had a circle whose radius was 5? Okay? What if the radius was 5? Once I travel 5 units on this thing, right about here I think it was, right? This would be 5. I'm trying to copy the other image I had as close as I can. It's going to suck. Okay? What would it be here? If I went 5 there, what would it be here? 10. This would be 15. And the little leftover piece? Correct? Give me thumbs up if this makes sense so far. Thumbs down if it doesn't. Okay. I want to find, where did it go? I want to find how many radians that is. That's going to be the S. Damn, that's the 3rd time I do this. You see the distance around that? Divided by R? That's the same idea. If I go from here to here, what's the distance I've traveled? 10 divided by my radius, which is, how many radians did I travel? S is the distance around, correct? And R is the radius? Okay, hold on. Did this one make sense to you?
Yeah.
Okay? This is exactly the same, but it's 5 times bigger, right? Because my radius is now 5. So if this was 1, then this would be 1 radian, which 5 over 5 means 1 radian. This would be 2 radians based on the other one, right? But this doesn't say 2, it says 10. But 10 divided by 5 is 2 radians. 15 divided by 5 is 3 radians. So it's still all just going to simplify back down to that single unit. Because it makes more sense with a unit circle, doesn't it? Does this formula make sense to you now? Thumbs up, thumbs down, sideways. Good. So? All we're really doing to figure out how many radians is we're going to take is to take the distance that you've traveled around your circle divided by the radius. So let's say this radius happened to be 4. And you know that we went around, and I don't know, this is going to be 28 for some reason. What's 28 divided by 4? That would be the number of radians you've traveled. Okay? Because a radian is simply me taking this little piece here. Let me copy that. Taking this piece, being able to flex it and wrap it around this way. And that would make 1 radian. Okay? Does that help? Okay. Please ask questions. It's hot, huh? No milk? Not hot. No. All right. We're good? All right, computing radian measures. A central angle theta in a circle of radius 12 feet intercepts an arc length of 52 feet. Please find the radian measure of theta. I'm going to just use my calculator here. Yeah, but I don't want to mess it up. What's my arc length? What's my radius? Right? Okay, I want you to turn to your neighbor, and I want you to figure out. Do you guys remember quadrants? What quadrant is this? 1. This is
2.
This is
3.
And this is 4. I know. I've been doing that. I have to tell you. Oh, I have something else to share with you guys too. But I've been doing that because I bought a pocket watch, and the 4 is 4 tick marks. I'm like, that's not right.
It's
And
not
then
wrong though.
It's not wrong though, because one of the kings did not like the IV on the watch, so he
Dude, you're throwing
demanded
up a
to
set right
do-
now.
Huh?
You just like threw up a set.
Yes. Okay, so here's what I want you to do right now. Now that you know this, I want you to turn to your neighbor, and I want you to figure out what quadrant this angle ended up in. I want you to figure out what angle this quadrant ended up in. Because it says an angle, right? And y, of course.
Yeah, probably the third.
Because then, or like something, a key to change or something, it seems like literally like 30 seconds. Kind of got changed. And then I dropped all my shades, right? And I dumped the shade on the ground. I thought like,
Waterfalls. Which quadrant was it in?
3.
3. Why is it 3? One person, please. Go ahead.
Because pi 3.14 would be splitting 2 and 3. So with it being 3.5, would go into quadrant 3.
Why couldn't it go into quadrant 4 though? How do you know? How are you sure that it's not in quadrant 4? What would it be? Okay, hold on.
That's 2 pi. Wouldn't that be like a pi and a half?
I'm sorry, I'm being picky with my math right now. Go ahead.
If you divide pi 3.14 divided by 2, that's just how much there is for one quadrant. So it doesn't go over that for the third quadrant.
Okay, so Merrill's argument is. You're Merrill, right?
Merit.
No, I was calling Merrill.
So you don't. You call me Carlisi. You call me by my last name.
I'll put my head down now. Okay, maybe it's just in my head then. So Carnici, Merrick, said 3.14 is here. That means that to get to 3.5, it's got to end up in here somewhere, right? And then my question was, how do you know it doesn't end up over there? And you said, Jay Jufrey,
What did I say?
something about pi halves.
Like if you divide 3.14 divided by 2, then that's how much there is for one quadrant. So, and it doesn't like exceed that.
Oh, so to get to the next part, because this would be another 3.14, right? So half of 3.14 is what, like 1.6?
Sure.
Right? So that would put you at like 4.7. So we haven't passed 3.5. It has to be in here somewhere.
That's what I
Okay?
said, pi and a half.
Yes. No, pi and means decimal.
Pi.
Pi over 2.
And that's 3 pi halves, just so you know.
Dum dum.
We'll talk about that later. No, dumb.
Yeah, Jay.
Can you say something else?
Okay, so people are already throwing numbers out. You had seen it before then. Pi is equal to 3.14, and you also know that it's equal to 180 degrees. So you should have these formulas to be able to convert between radians and degrees. It's just the dimensional analysis. Oh, I like the way that sounds. It's just dimensional analysis. Pi radians is equal to 180 degrees. So depending on where you want to turn to, you'll use some proportion or some relationship to this proportion. I missed it. Of course I am. I haven't taken attendance. Where'd Reese end up? Because he's not here. Nate Duran?
right.
There you are. I'm so used to seeing you here. That's my own fault. You guys have those formulas?
Yes.
Yeah. Okay. Go ahead and no?
No, it wasn't.
All right. Go ahead and convert these to radians, please. No, they should be in pi. You should leave them in pi form.
Oh, I should leave them.
You should leave them with pi. Yeah, so you want to leave them with pi form, or with pi in it, because that's more exact. So 60, pi, 180. That simplifies. That's 1/3. So this is pi thirds. Okay. 270 pi over 180. Gone. Goes at 3 and 2. So this is 3 pi halves, which is what we were talking about a minute ago. Mer. What? You can't do that?
No, I said.
And then here, 300 pi over 180. What is that? 15, 59, and then 5/3.
Why is that one circled?
Because I want to make sure the negative stays in there. I don't want people to think that it's an equal.
You know how you always come over and like touch my phone case?
I know.
Mr. Malik does the same thing, and I'm like, Munoz does that.
We're weird like that. Okay, go the other way.
Oh, I know how to do this.
Ooh, that's nice. Yeah.
Oh, that was the answer?
I know, I'm trying to block this, which I think people already got anyway.
Dang it.
I was not paying attention. You just give out the answer.
No.
I did, yes.
Oh, I already got that.
Wait. Oh, okay. No. And then I just love how those 6
Should be pretty close to 360. So multiply that.
Oh, okay, so.
Should be pretty close to 360. So 6 times 180 divided by, oops.
Oh, yeah.
343, 344 almost. See?
Wait, how'd you get 6?
I thought about like.
Six times. Yeah, that's what I did. I got 1,080.
It's 240.
Oh, I said
Guys, take a minute, stand up, stretch, wakey wakey.
just dance break.
I can't do it anymore. Did I tell you that I was getting
Why?
they were getting flagged for copyright because I had people's music on my channel, and I could either put commercials on.
You're kidding.
No, they were all getting flagged after we did that.
I
So it's
didn't
like
know you were
either-
still recording that.
Yeah, I thought you could like turn it off.
Like
Yeah, I could probably pause. I could try to pause it some other time. Try to pause it.
It's just dance break.
Just dance break. We need to do that.
The only one dancing.
So as we're doing these, you're gonna want to look for some of the patterns in here. You'll start to see that some of the fractions, the denominators, are kind of associated with specific types of angles. For example, the top one, that's gonna be 45 degrees, right? Because if you take 180 divided by 4, what are you gonna get? You're gonna get 45. So if you have one of those, then it should be 45 degrees, right? If you take 180 divided by 3, you're gonna get 60. So 4 60s is negative 240. There you go. And then that one's just a little bit tougher because it doesn't have pi in there.
Wait, can you do B?
Can I do B?
Wait, so is there not supposed to be pi in A and B?
No, pi will cancel out. Pi doesn't cancel out here because there's no pi there.
That makes sense.
Because remember, pi's gonna end up on the bottom, right?
I got
So then it'll go pop, gone.
Wait, can you do one? Can you? Yeah.
Can I do one of them?
You do B.
Can I do B?
Do B.
Doobie. A doobie. So 180 over pi, that's a 1. That's 9.
That's 6.
Oh, that's 6. Just kidding. 4 times 6 is 24. Add that 0. Right?
What does that say?
Nothing. It's just.
Ayo.
Let me try that again. So negative 4 pi thirds. I multiply by 180 over pi. Pi makes 1. 3 goes into 18 6 times. 4 times 6 is 24, and add that 0. But this is going to be negative. So 240. Okay? Okay, let's move on. Oh! If I did do a whole rotation like that, I travel 360 degrees. What's another word for a rotation?
Circle.
Starts with an R. Ends with evolution.
Revolution.
Yeah, right? So if I did it one whole revolution, how much did I travel? And in radians? 2 pi. Okay? So that's what this is saying. One full revolution is 2 pi radians. Half a revolution would be pi radians.
So it's just giving you a shortcut instead of having to do math.
It's just telling you what, yeah.
What would be an example of using this like in real life?
Revolutions? Yeah, actually, that's used a lot actually. Your tires, revolutions, the revs, engine, pop, pop, pop. They use that a lot when they're creating the. If you go on like Ferris wheels and stuff, the revolutions and speed, you don't want to exceed that where you're not offensive to people, kind of thing. So revs are used a lot. Rev your engines. Okay. Negative pi 4s. Do we need to do that? To the revs?
Is the second one? That's 3 pi.
Yeah, this would be 3 pi over 2. I think we kind of said that already too, didn't we? No, not really.
No.
Informally.
See, I feel like we did this in rounders, but we didn't learn actual math. It just gave us the picture of like the
The
radius
circle.
thing.
Oh, nice.
Yeah. And expected us to
I
learn
knew
the
you had to
whole
do.
thing.
we did at the end of the year.
Yeah, but he
Yes.
expected us to memorize the whole thing instead of
No, I'm going to show you some stuff. You'll memorize them, but you'll hopefully know them. Okay? You should know them. No, because you won't be allowed to circle. So, how much time do we have left? Okay, you know what?
I'm gonna have to retake this test then.
No, you won't. No, you won't. What do we got, like 7 minutes? You're okay with degrees, right?
No. No, my problem is I just can't memorize it.
Okay. So then don't memorize it, just build it. Build it and they will come. Well, we'll just go as far as we can, and then we'll pick it up tomorrow. Sounds good? Okay. That's perfect. Perfect circle. So, all right, unit circle. What's the assumption with a unit circle? That the radius is
360.
What?
Yep, never mind.
the radius is 1, okay? So, let me use some different colors here, and you can just watch. We'll build this again tomorrow, and then we'll go deeper into that. How many degrees are we here?
0.
We're at 0, right? And then we go up to 90 degrees, then we go up to 180 degrees, then 270, and then finally, once we make a full revolution, we're back at 360 degrees.
If the radius isn't 1, you just multiply everything by the radius.
And I'll show you how to do that with this one, okay? There's going to be a couple of numbers that we will use a lot. And you should have seen these in geometry, okay? Pretend it's a square. Pretend it's a square.
A trapezoid, but on the side.
Where my sides are 1, 1, 1, 1. Okay? What are all my angles?
90.
They should all be 90s, right? So let's do that. We're okay? Sharice? Okay? Skeptic. So, if I cut this in half, and just not look at the top piece of it, I've changed some properties here, haven't I? What did my angles become now? Because I cut it in half, didn't I? So these are now 45. What's my hypotenuse here? I'd have to use Pythagorean theorem. 1 squared plus 1 squared, and then take the square root of that. So that's this guy. Oh, you remember this? What do we call him? We call him 45, 45, 90. So creative, right?
Yeah.
Write this guy down. Put him in your notes.
And then 30, 60, 90.
Yeah.
We'll do that one right now.
That was like a traumatizing time in
Well, I
college.
thought we did circles. Why do we need to do triangles?
I'm sorry, I forgot to dig up those skeletons because
Wait, Mr. Munoz, I
Sir?
thought we were doing circles. Why did we switch to triangles?
I'm going to tell you right now.
Let me tell you.
Do you get this?
Yeah.
Okay, good. Then just start with that. We'll start with that,
Why is
and then we'll build on it, okay?
Could you do a squared plus b squared equals c squared? No, a square root of this.
One plus
So
You okay so
1
far?
plus 1 is square root.
All right, cool beans. Everyone got this triangle? If not, then here we go.
So then the square
I want to, so this is an important triangle. We're going to be talking about it a lot. And it really only had 2 angles, right? 45s and 90s. So I'm going to break up my circle into 45s. So that means I should have one here, one there, here, 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 and Everyone agree with that? Right? Okay. Now I know that this is going to be 45. This will be, what is it? What is that? 135?
Let's go with yes.
Okay, and then whatever the other 2 are. 225 and 310? 315. Okay, cool. So, In radians. In radians. What is this, guy? It's pi, right? How many pieces did I break up the top pi into? 4. So this is my first fourth of pi. This is my second fourth of pi. This is my third fourth of pi. And this is my fourth fourth of pi. Does that make sense?
Yeah.
So this is pi fourths. What does this simplify to? Which is simply pi over 2, 3 pi fourths, and 1, right? Question. Sticking to that same theme, what does 225 become? If this was 4, then this would be 5 fourths of pi. 6 fourths, which is 3 halves pi. This would be, hold on, where did it get halves from? Someone feed me a half?
That's right.
Oh, it is, because it's simplified. JK, fine face. LOL. What's this one? 7 fourths? And this one would be 8 fourths, which is 2 pi. Does that make sense? 3? Cool, we'll do the other ones later. Manana. Have a great day.